Fine. Hi, everyone. Our team's topic is financial sentiment and market correlation analyst, and I'm Javi, and my team with Jinsong Liu and Ziyang Lin. Um, First, let's move. First, our part is combined with three parts: the data collection, the fiber indicate, and the correlation and dashboard part. Let's move to our data pipeline. We divide our correlations process into two streams. First, you can see that we utilize the Yahoo Finance API to extract the daily OHLCVs vectors is open, high, low, close, and volume. And we ensure full historic coverage from January 2023 to December 2024. We pre-propose these data to alias the timestamp and filters out the non-traded data, establish a clean tempered backbones for our models. And you can see on the left, it is our market data collections, just as I said before. And on the left is our soft data, the news data. However, the real challenge arose when we cross the news data. To overcome the API limitations, we engineer a custom solutions. We build a specialized crackers using the GNews and implement a monthly time slice strategies. Instead of querying the whole timeline at once, we break this into every month to get a news. So next, occurring the raw data was only half of the battles. Upon the inspections, we immediately encountered a challenge, the semantic ambiguities. You see that when search engine treats Apple as a generic keywords, we don't discussions between the tag correlation and the fruit. So we build backwards applications to solve this. The standard stop words list was important. Instead, we engineered the special solutions, a configuration-driven denews pipeline, and you can see on this. Next, Ziyang will talk about the FinBERT and the sentiment score.
Okay, hello everyone. So my part of the project is the NLP pipeline, basically turning thousands of the news headline into a usable daily sentiment signal. We began by collecting headlines for each stock like Apple and Microsoft. Each line is passed into FinBERT, which is the model trained specifically on financial text. So it understands the tons of news like earning, regulatory issues, product release, and etc. FinBERT gives us a sentiment score for every headline, and then we aggregate all scores from the same date into a daily sentiment index. Here on the slide, you can see the raw headlines on the left and the final daily sentiment output on the right. This becomes the key input for our later correlation and prediction models. Moving to the next slide. In this slide, expand how our FinBERT pipeline works. FinBERT is a version of the BERT training entirely on financial documents. For each headline, we get three probabilities: positive, negative, and neutral. To turn that into a single score, we simply take positive minus negative, giving us a value between -1 and +1. The left side of the diagram shows the data pre-processing, loading the CSV, selecting the date and the text columns, rename them, and initialize the FinBERT model. The right side shows the inference step. We pass the text through FinBERT, take the softmax, and get the correct positive and negative index from the model and compute the final sentiment score. This becomes the building block for our daily sentiment index. And the next slide is after generating sentiment score for each news headline, we convert them into a usable time series signal. Each date have many headlines, so instead of looking at them individually, we simply average all the sentiment score for that day. This gives us the daily sentiment index shown in the table below. Positive values indicate overall optimistic news tone, while negative values signal means a more negative news days. This daily index is what we later compare and correlate with daily stock returns. And the next slide is the final daily index for Apple after aggregate all FinBERT score headline. You can see from this example, the sentiment fluctuates heavily from day to day and sometimes sharply positive, sometimes sharply negative, which reflects how sensitive the market narrative to the news event. This time series is what we use later to analyze correlation and build our predictive models. And the next slide will illustrate by my friends.
Okay, thank you, Tim. So here we analyze 5 large-cap technology stocks: Google, Apple, Meta, Microsoft, and Amazon. For each ticker, we aggregate thousands of news and article using a FinBERT-based sentiment model and compute a daily average and sentiment score. And then we measure the Pearson correlation coefficient between the daily settlement and the next day stock return. So let me briefly expand the key column. News article and average per day shows the scales and consistency of news coverage. Settlement means reflect the overall polarity of a news during a simple period. And the next day correlation measures the linear relationship between sentiment and next day return. So from the result, we observe that Google shows the strongest relationship, which is marginally significant at the 10% level. Apple also exhibit a positive correlation, though weaker and not as statistically significant. Other stocks such as Meta, Microsoft, and Amazon show very small or near zero correlation. Although these correlation values are relatively small, this is expected in financial market where prices are noisy and influenced by many factors. Importantly, the results suggest that news sentiment doesn't act as a standalone predictor, but rather provide a weak yet consistent signal that can be valuable when we combine it with the market features. Okay, when we go next step, um, so on this slide, we visualize the relationship between news sentiment and daily stock return using a scatter plot. So each data point represents one trending day. On the x-axis shows the aggregate sentiment store ranging from -1, -1 to +1. The y-axis shows the corresponding daily return percentage. So these scatter plots provide us an intuitive explanation for the quantitative result shown on the previous slide. So it demonstrates that sentiment carry a weak but directional signal, which is not sufficient on its own, but we can become useful when we combine them. So we can go next page. So in this section, I will move from correlation analysis to feature aggregation and predictive modeling. Here we show two LSTM-based neural architecture implemented using TensorFlow and Keras. Both models are trained under the same experiment settings to ensure a fair comparison. So on the left, we have the base model, which use 5 traditional market features: open, high, low, close, and volume. And on the right, we have our advanced model, which extends the base model by adding a FinBERT-derived sentiment feature, resulting in 6 input features. And this allows the models to jointly learn from historical price and the aggregated news sentiment. So then we can go next. I can show you the dashboard about our project. So here, this is our dashboard. At the top, we display the current market price alongside the daily aggregate sentiment score, providing intermediate context on how recent news align with the market movement. The central section focuses on the model performance metrics, where we directly compare the base price only model and the advanced sentiment enhanced model. Below that, the dashboard was showing visualize daily predicted errors, highlighting how the sentiment-aware model reduce short-term deviation from Guangzhou's price. And the central panel present a time series comparison between the actual closing price and base LSTM model, and the advanced sentiment augmented model. This visualization clearly show that the sentiment enhanced model are more closely track real price movement, especially during periods of increased volatilities. So to conclude, our project demonstrates how financial news sentiment, when poorly aggregated and modeled, can serve as a valuable complementary signal to traditional market data. And that's it. And thank you, everyone. This is our project.